has started.
So now remember, for gear ratios, we're talking about the size of the gear, and to find the size of the gear, we're counting the number of teeth. Remember, the teeth have to be evenly spaced. So since the teeth have to be exactly the same space from one gear to the next, or they don't mesh properly, just counting the teeth will allow us to compare sizes. And it's always the driven gear on top, or driven gear first, and the driving gear second. Well, how do we know which is which? Well, if we separate the gears, the one that keeps turning is the driving gear. So we separate these. This gear is the one that keeps turning. It's the driving gear. It has 1, 2, 3, 4, 5, 6, 7, 8 teeth. Driving gear. The other gear is the one that will stop turning if I separate them. That's the driven gear. That has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 teeth. Now we can reduce this. Now remember, we do not want to turn this into a mixed number. We want to leave it as a fraction, even though it's improper. But we can still reduce. We can divide both 12 and 8 by 4. So that is a 3-to-2 gear ratio. That describes not only the ratio of the teeth, but also the ratio of RPMs and the ratio of the transfer torques. Number 2, compression ratio. Remember, compression ratio is the expanded volume over the compressed volume. Here, the expanded volume is the 280 cubic centimeters. The compressed volume is 35 cubic centimeters. Cubic centimeters here will divide out. We have 280 and 35. Now, the compression ratio is one that we do always reduce to a unit ratio, which means the bottom number has to be 1. So I'm going to divide by the bottom number. 35 divided by 35 is 1. 280 divided by 35 is 8. So that's an 8-to-1 compression ratio. The third one here is one that we really haven't looked at yet, but very important for those of you in the auto maintenance class. A transmission ratio. A transmission ratio is usually made up of 2 or more gear ratios. So we have a gear ratio right here. The 24-tooth gear is hooked to the engine, to the crankshaft. It is driving. If I separate the 2 gears, that one's going to keep going. So that 24-tooth gear goes on bottom. It's meshing with the 30-tooth gear. That's our driven gear. That goes on top. Let's first reduce these. Both 30 and 24 divided by 6, giving me a 5-to-4 gear ratio for that first set of gears. Now there's 2 other gears over here that are meshing. In this case, the 16-tooth gear is the one that is more directly linked to power. So if I separate those 2 gears, the 16-tooth gear is going to keep running, keep moving. That's my driving gear. The 24-tooth gear would stop. That's the driven gear. Once again, let's reduce those. Both of those numbers can divide by 8. 24 divided by 8 is 3. 16 divided by 8 is 2. So that's a 3-to-2 gear ratio. To get the transmission ratio, we take the 2 gear ratios and we just multiply them together. 5-to-4 times 3-to-2, we just multiply them like we would any other fractions. 5 times 3 is 15, and 4 times 2 is 8. Transmission ratios will appear on a quiz sometime soon, possibly tomorrow. Okay. So we have these ratios and these rates. The next step is doing something with them. And generally what happens is we have a set ratio. We want a ratio that's equivalent to it, but with different numbers. Now remember, the difference between a ratio and a rate is a ratio compares two numbers with the same labels or same units. So there's no units in the ratio itself. A rate compares two numbers with different units or different labels. So we do have to have labels within the rate itself. But let's look at ratios. Let's say we need a 3 to 5 gear ratio. And we have a motor that already has a gear on it that has 35 teeth. To guarantee that we have equivalent ratios, we need the 3 to 5. We're just going to set the two ratios equal. The motor, the gear that's connected to the motor would be the driving gear. So the 35 teeth go on bottom. We need to know what number to put up here so that we have two equivalent ratios. This setup here, as we saw when we did percents earlier in the course, is called a proportion. A proportion just comes from two equivalent ratios. To solve a proportion, as I look at this, if this were just an equation, let's say this were the variable x here, if I wanted to solve that, I could multiply both sides by 35. And I would have 35 over 1. This would technically be on the left side here. 35 over 1 times that. So I'd have 35 times 3 here over 5 equals x. And now, right now, I'd calculate that out to solve it, but I could multiply by 5 on both sides right now to get rid of that fraction. And what I have here is 35 times 3 equals x times 5. These two products that I got here are very important because if I look at where they come from in the proportion, 3 times 5 is right there, or 3 times 35, I should say, or 35 times 3, and the 5 times x is right here, or x times 5. They are what we call cross products. They're called cross products because they form a cross in the proportion. They're diagonal. We multiply the numbers that are diagonal with each other. And they have to be equal, as we see down here. So back to that original proportion, 3 to 5 has to equal x to 35. If I want to solve that, I do the cross products. So this diagonal here is x times 5, or 5x, has to equal this diagonal here. 3 times 35 is 105. Then I can solve that equation by dividing by 5. X equals 105 divided by 5 is 21. So that if we had a motor with 35 teeth on a gear already connected to it, and we needed a 3 to 5 gear ratio, we would have to mesh that 35 tooth gear on the motor with a gear that has 21 teeth in order to maintain that gear ratio. Let's say that for a loan, you need a 2 to 5 debt to income ratio. You currently have between credit cards, car payments, and everything else, $700 a month in debt payments. You want to buy a house, that would be $450 a month in payments. What do you need for minimum, really, monthly income? Well, we need a 2-to-5 ratio, debt to income ratio. You already have $700 a month in debt. You want to add $450 more to that. If we add $700 plus $450, that's $1,150 a month in debt. The 2 represents the debt, so the $1,150 goes on top. We want to find what's the income we have to have. That's going to be our X. So we do our cross products here. $1,150 times 5 is what? 5, $5,750. And 2 times X is 2X. I'll double check that. 1,150 times 5. It is $5,750. And then to finish solving this, I divide by the 2. $2,875 equals X. So your gross income for the month has to be at least $2,875, or you will not have that minimum 2-to-5 debt to income ratio. Or let's see, we could use a rate. You might have, let's say we're looking at your net pay. Your gross pay would be easy to calculate, but your net pay after working 24 hours for a week, you take home, your take-home pay is your net pay. Let's see, let's do $144. How many hours would you have to work, assuming your tax rate stays the same? Would you need to work to take home $240? So we can set up this rate however we want to. We can put hours on top and dollars on bottom, or dollars on top and hours on bottom. It really doesn't matter. Typically with rates, we're used to putting time, anything related with time, as the second number, as the bottom number. So $144, 24 hours. Notice that there are units in here because this is a rate. We're comparing 2 things with different units or different labels. On the other side here, we have $240. Now, I told you it didn't matter where we put the dollars or the hours in this first rate. That's very true. But once we have made that first rate, then the second one has to match it. So since dollars were on top in the first rate, we have to put dollars on top in the second rate. So the 240 goes on top. Whatever we put on bottom here has to be hours. And of course, that's our missing number that we're trying to find. We're going to call that X. So let's cross multiply here. We have $240 times 24 hours. What is that? $5,760 times hours equals, going the other direction, we've got 144 times X. That's 144X. To solve that, 5760 divided by 144 will give us 40. We divide by 144 on both sides. 40 hours equals X. So if we worked 40 hours, we would earn that $240. Well, this is kind of the long way around of cross-multiplying and creating that equation to solve. You might have noticed in every equation we created, we had a simple equation, then to solve it, we had to divide by the number that was with the X. Here we had the cross multiplication, we divided by the 2 that multiplied the X to solve it. Here, after we did the cross multiplication, we divided by the 144 with the X to solve it. So if I have that type of a proportion here, $144 over 24 hours, and I'm comparing it to $240 over X, there is a shortcut. Rather than doing the cross products and writing the equation, I can simply shorten it to something called cross multiply. And divide. Now to do that, I take the diagonal that has 2 numbers on it. That's this one here. And I am still going to multiply those. $240 times 24 hours is 5,760 dollar hours, technically, would be the units. So those 2 numbers that are diagonal still get multiplied. That is the cross multiply portion. The third number that is diagonal to the missing number, so in this case, that's the 144, is diagonal with the missing number. We divide by that one. So 5760 divided by 144 gives us 40. Now it's really not really a lot less work. It just saves us from setting up the equation and then solving the equation. So it makes life go a little faster. Let's say we need a compression ratio of 7.5 to 1. So that's 7.5 over 1. Find the required expanded volume if the compressed volume is 28 cubic centimeters. So the 7.5 is the expanded, the 1 is the compressed, so the 28 cubic centimeters goes with the 1 on bottom. So this is the number we're looking for up here, the expanded volume. Now you'll notice I did put the cubic centimeters in here. All that's telling us is that whatever goes up here also has to be in cubic centimeters. So we can really ignore the units other than that. Now we'll cross multiply here, 7.5 times 28 gives us 210. And then we divide by, well, 1 is what's diagonal to X, so dividing by 1 doesn't change anything. That's just going to be 210 cubic centimeters. We might need a pulley ratio of 7 to 4. Motor has a 10-inch pulley on it. Oh, correctly. Oh. So how large does the other pulley have to be? Let's do, what size should the other pulley be? So 7 to 4. Remember, the 4 is the driving and the 7 is the driven. So on the other side of this, the motor would be driving. So that 10-inch pulley goes here. Now again, all that really tells us, the inches tell us, is that we have to have inches on top. That's going to be X inches. So to find that, we'll do our cross multiply and divide. The two numbers that are diagonal are the 7 and the 10. So we do 7 times 10 is 70. Then the number that's diagonal to our missing number is the 4. So we'll divide by 4, which gives us 17.5. So X equals 17.5 inches. 17.5-inch pulley is what we need there. Now, not all of our proportions should be solved with that simplified method, the cross multiply and divide. We might have x plus 7 over 36 equals 10 over 24. To solve this, cross multiply and divide would not be practical because x is not by itself in its location in the proportion. All the ones we've done so far, x has been all by itself in its little section of the proportion. Right there, x was all by itself. Here, x was all by itself. We had the label, that was it. It was just, x was the only number. Down here, however, it's not just x by itself, it's x plus 7. So here we really should do the full cross multiplication, write the equation, and solve it. So going in this direction, we have 10 times 36, that's just 360, equals, going in this direction, we have 24 times x plus 7. And that is an equation we know how to solve. We see the parentheses there. That tells us we should do something there first. So there's nothing to do inside the parentheses. X plus 7 cannot be combined. So we'll multiply by the 24. 24 times x is 24x. 24 times 7, oh, what is that? 168, I believe. I'll double check that. It is. And now we can solve this. We'll subtract 168 from both sides. Gives us 192 equals 24x. And we'll divide by 24. 192 divided by 24 is 8. So 8 equals x. So that's telling us x equals 8 in that proportion. Now, similar to that, we might have 18 over 5x equals 27 over 60. So we have the same type of situation here. Because x is not by itself, we're better to go ahead and do the full cross multiplication and write the equation. So going in this direction, we have 27 times 5x. I can multiply that out. 27 times 5 is 135x equals, going this way, we have 18 times 60. What is that? 1,080, I believe. Let's try that. It is 1,080. So we get the equation 135x equals 1,080. We're going to solve that by dividing by 135. So x equals 8 again. Now, both of these could have been solved just by being very, very careful with the cross multiply and divide. We still would have ended up with an equation. Not 20. But what we could have done was this. We could have done cross multiply and divide. 36 times 10 is 360. Divided by the 24 would have given us 15. But what we would have to remember is it's not x equals 15. It's x plus 7 that equals 15. So we still have an equation to solve. We would have to subtract 7, get x equals 8. Would have done a similar thing over here. (27/60). We could have cross multiplied. Oops. 18 times 60 would be 1,080. Divided by the 27, because that's diagonal to our variable, would have given us 40. Oh, no, it's not. Is it? It is 40. Okay, so we get 40. But remember, it's not x equals 40, it's 5x equals 40. And we would have had to divide by 5, get x equals 8. To me, it's a lot less work and a lot less likely to make a mistake if we just do the full-out cross multiplication, create the equation, and solve it. In fact, there are some times where we have no choice. There are no shortcuts. Like here, we have x over 4 equals 9 over x. Yeah, the variable appears twice. Doesn't seem horribly fair, but it works. What we would do to cross multiply here, going in, let's do this one first. Going in this direction, 9 times 4 is 36. Going in this direction, x times x is x squared. So we have that equation, 36 equals x squared. The only way to solve that is to square root. The square root of x squared would make it x. Now, the square root of 36 we have to be very careful of. There's actually two answers there. 6 or a negative 6, because negative 6 squared could also give us 36. If we look at this, 6 over 4 is a 1.5 to 1. 9 over 6 is a 1.5 to 1. But a negative 6 over 4 is a negative 1.5 to 1. And 9 over negative 6 is also a negative 1.5 to 1. So either of those answers would work. Or we could have a system like this. The variable appears twice, but it's not going to give us an x squared. Still, we would end up cross multiplying. In this direction, we have 6x times 21. Well, 6 times 21 is 126x. Equals, going in this direction, 45 times the 3x minus 1. I'm just going to put that in there, 45 times 3x minus 1. Now we would have to solve this equation. We have to simplify. On the left side, there's nothing to do. On the right side, we have to distribute that 45. 45 times 3x is 135x. 45 times negative 1 is a negative 45. Now we have to solve this equation. Now, normally, we would get rid of, when there's an x on either side, we would get rid of the smaller one. But here, the 126x is the smaller one, but it's the only thing on the left side of the equation. So if we try to subtract it, we're going to be left with nothing or 0 over there. So in this case, we are going to subtract the 135x from both sides. 126 minus 135 is a negative 9x equals. Over here, that cancels out, it's gone. So we're left with just a negative 45. So we solve this by simply divide by negative 9 to get x equals 5. Now, you're not going to be, in real life applications, you're not going to be doing too many proportions that look like this. But those simple proportions we did up top, the gear ratios, the compression ratios, the debt to income ratios, any of our rates, the pay rate, we could have done a speed and distance traveled or speed and time traveled. Proportions really are the most powerful tool in math. I would say 90% almost of math can be done with proportions if you know how to use them. There's variance, variability, whether you're dealing with direct variation, inverse variation, it still comes down to proportions can be used to solve it. Bless you. Our homework for today, out of the book, page 288, it is exercise 7.2, problems 1 through 89, the odds. So we've got about 15 minutes left. If you'd like, you can start working on those. I'll be here to answer questions if anything comes up. Otherwise, if you want,